Hi, and welcome to yet another video in AI in C#. This video is a companion video to my video about how to turn an open source C# library um, into an MTP package, but it can also be seen as its own. But if you haven't seen that video, I would recommend you at least skim it before you go. But I have made a NuGet package in terms of AI. It's called SimpleRag, and the reason for it is that while AI in C# is actually rather easy, it's easy to make a chat, it's easy to do function calling and such things. RAG is not hard as such, but there's just a lot of concepts that you need to understand. So it's not the individual parts, but binding them all together in the right format is the one that is difficult, because there's vector stores, there's embeddings, there's chunking, and just putting them together can be rather difficult. So SimpleRag is my way of trying to say, okay, let's make this easier so you can focus on some of the more interesting stuff. The SimpleRag package is open source, MIT, so it is totally free. And I would love some contributors if someone wants to add more sources, as we're gonna see. But else, let's dig in and see what it's all about. So, in my previous video about using this, I had a small solution for a small open source project where I use it in. And I just had a backend, and it linked to a NuGet package called SimpleRag. As you can see, it's very early days. I'm using it actually in production myself, so it's not like totally broken, but there is subject to change. So be warned if you go about and use it. It's fairly new. It lacks a few XML summaries and stuff. But beyond that, it is actually possible to work with. So it's a normal NuGet package, but here I have actually downloaded the code. Again, the code is just on GitHub, and you can just go and grab it for free. But I downloaded it here and put it in as a project instead, so we can actually go step by step through how all this works. And that's what we're gonna do. So we're just simply gonna set a breakpoint down here. And in this case, we're gonna use a Azure client down here. So you can see whenever you use this, you need to go in and make builder.services.add SimpleRag. And if you want to do SimpleRag locally, meaning you put it in, you take it from local files on your machine, a cloned repo, because you don't want to, you want a quick and easy iteration, you can do that. Or we can go in and do it with the GitHub integration that can go in and grab the data off GitHub instead of the local files, and then rag them. In my case, I'm using GitHub integration, and I think we will just let it start. But behind the scenes of SimpleRag here, all it does is it news up or it dependency injects a few things like how to get hold of the data in the vector store, how to put data in the vector store, the vector store itself based on which vector store provider you want to use, SQL Server, Azure, AI Search, Quadrant, or for example Cosmos DB as well. Then it dependency injects its chunkers. So it has a C# chunker and a Markdown chunker. And it has some source commands that takes care of doing this work. Then it has access to GitHub whenever we use the GitHub integration version. And it has access to grabbing files and treating them as content. And then it has its two main endpoints, ingestion and search, which is the ones we are gonna work against. So whenever we start this code, and in my case, the code is running as a Azure function. So in order to kick this off, we're gonna set a breakpoint here, and we're gonna go into Postman and start it out. And once we do that, we hit our breakpoint. And what it does here is it's just checking, hey, is the API key sent along the same as the ones I want? So only me should be able to sync the repo. And in this case, it is. Then you can see I have two constants here, which is my GitHub owner and repo. And I'm using two sources here. I'm using a source for GitHub, for C# and a source for Markdown. And the only thing I put in further is a small action that can give us some notification back whenever what it does now. Now it downloads, now it ingests, and so on. And that's just put out as a console.write line, but you could do whatever with the GUI you make. These sources here, if we look at them, are all have data sources as a base class, but the GitHub versions have some more GitHub data. It has a GitHub owner, a repo, and a last committed timestamp, which I don't use in this solution, but it's meant to, if you know when you last got data, you can store that timestamp in a database or a file, and then it would be intelligent enough to see that if nothing have happened in that repo since that timestamp, it wouldn't say this need to be put into the vector store. The data source itself is also fairly simple. It will have something called a collection ID and an ID, meaning a source ID. And this is because if we go into a SQL Server, let me quickly open a SQL Server Management Studio here and show the data at the other end. So close this down and get a SQL Server that's opening on my other screen, so it will come over in a bit. So here we are. So this is SQL Server 2025, which is the only one that supports this. And behind the scenes, there's only one database, or there's a database, and each simple rack is one table, which in case this one, I use this database for other things. But inside this, we will see that there are data, and the data is code and Markdown. And so the source is code or Markdown in code, and the collection is all Trello.net. So that means that if you wanted to put multiple repos into the same, it is possible with this solution. But it's a very opinionated solution, so you don't choose what columns are in this table and such things. These are meant to hopefully fit all kinds of RAG data. If not, there might be some breaking changes in the early days here. But these are just things like where is the code or the files that we need to rack located, what part, what are they recursive, we need to get them, is there certain patterns we need to ignore, and is there some files that are so big that we don't want to even rack them because there are some auto-generated stuff that we don't need. So if we go back into the repo here and start out, we can see that I'm doing this Trello.net collection with code as the ID, recursive in my file source. So if we look at Trello.net's structure here, it is this folder I want to do, so I don't want all the other folders. And so I want all these folders, but not this one, which is my tests. So I'm excluding those as an ignore pattern. This is just regex ignore patterns. So if we set up breakpoint in here, we can now see that we got two sources here. One for C# GitHub and one for Markdown GitHub. There is some options we can pass along. We don't do that here, but that is so we can change the format of the data we have in here. So this is the content that are being vectorized. So for example, if I find a method here and show it to you, this is what we are vectorizing, and I will explain why this format is the way it is in 1 second. And this is essentially just a setting that makes it possible to say, I don't want it like that, I want it in a different way with more information or less information. We set up some events for some notifications that we need to pass along, and then we just start the different sources. So we can see here that the first source is a C# GitHub source. So we just try to step into that. We will check that we have a path, which we have, and we will set up the events for notification. And then we go in, because we are in a GitHub part, we need to get each file that are a C# file up here. And for doing that, we need to have a source. And in this case, because it's generalized, it's a file content source for GitHub. So we take our original source, which had the repo and so on, and quickly turn it into a file source. And if we go into this, we will then see that we will begin to use GitHub in order to get this data. So we first check if we have provided the repos, and then we create a GitHub client. So right now we are into what is called OctoGit, which is just a NuGet package for C# to work with GitHub. So we check that we have our token, and we go in and work with that. So we have a GitHub client, and we go in and check when is the last commit for this. In my case, it's this jar, and I think it was a couple of days ago. Yeah, 2 days ago. Then we go in and get the tree. So essentially we are getting this tree with all its nodes. And we go in and begin to find all nodes that fits our path. So it needs to end with the file extension .cs. So in my case, I end up with 361 things, and it will begin to each one of them grab the content of the file. So I'm hitting some ignore files, and once I hit the first file, which in this case is my API call exception option CS, which is just one of the files, it will use GitHub and OctoKit's API to get the content of that file. So inside that file is this, which is an enum. This will take a while, so I will just set a breakpoint here, get rid of these, and we will see that it will now take every single file up here. So while we are waiting for this and hitting this breakpoint, we'll just go out and see what is behind the scenes for the rest of it. So we are going back into our C# ingester here. Which will hit this ingestion at some point. So again, it's working. I'm not gonna wait for that. But when we hit it, we'll begin to actually say, now we actually have all the content of the repo in memory as strings, meaning we have these files. So we should be able to go to each file content, which are here, which just have part of the content, and begin to actually turn it into things. So now it's done. So we go in here and we begin the ingestion down here. So what we want to do is we want to take all that content and turn it into what is called C# chunks. And a C# chunk is something that have a kind. So it could be an interface, a delegate, an enum, a method, a class, struct, a recorder, or constructor. We need to find what namespace is, what the parent is. So if it's a method, what is the parent class? And what kind of is it a method on a class or is it a method on a record, for example? Then the name of the method, class, enum, whatever we have, the various XML summaries, the value, meaning the content, if it's a method, it's the method signature, dependencies, and a few other things like references, so we know who calls this and what called it. So if we go in here and look at, we get a file out. So the first file is again this API thingy exception, and it was with this code. We quickly split it up in that it has 22 lines, so we can figure out if there's more lines than what we have defined. And then we get code entities. And code entities is our chunker, which is up in the data sources C# chunker here. And it will use Microsoft Code Analysis, meaning Roslyn, to get it as a syntax tree and get the roots, and then we can begin to find our various things here. In our case, it was an enum, so let's jump in here. I won't go into every single little detail of all this code, but it's essentially just using the Roslyn analyzer to grab stuff in various parts of code and turn it into objects. So in this case, we are grabbing all enums that are in here. So there should be one, which there is. We check if it's public, because this tool is set to only rag public methods. At some point, it probably will be made a configuration in a later version of SimpleRag. But when you're using a public API, of course, you only can hit the public methods. So why pollute and make the AI confused that there is internal private classes and internal classes and so on. But we just grab it. We grab the namespace, which is in this case Trello.net. We grab the XML summary of the specific enum. And in terms of enums, yeah, we get the parents, which is nothing because it's by itself. And then we get the node.toString, meaning if we look at what that is, that's the value we put in here. So we just take the entire enum and rag it as one big part, because it wouldn't make too much sense to take this specific part and turn into a specific ragged entity, because there would be too little context of what this is. It would be a little like taking a book and then ragging every single line instead of paragraph or chapter. So in this case, when it's an enum, we just rag it as, or we make it into a chunk of one big enum. But if we go in and look at, for example, methods, we can hit a method down here at some point. So we find a method, which is a process JSON from web async in this case. There we will go in and get the name, this XML summary, and the content, but the content without the body, because we don't need to, again, expose that. We just need the method signature for an AI to be good enough at understanding that. We get dependencies. So for example, what kind of parameters are needed, what is the return value, and so on. And in the end, after all this, we end up with the various code entities. So I will just set a breakpoint here and let it get through the 300 different files and get rid of these breakpoints. So the code entities are not made. So there's 881 of them, which are, some of them are enums, some of them methods, some of them constructors, and so on. And we end up building our final value, which is this. And in my case, you can see that I'm making it XML-like structure. So I'd say it's code. The method is called this. It is a method. It is in this namespace. The parent is a class, which is the sticker class. And then it takes the XML summary and the method signature, and that's it for this one. While if we take a class, see what we have here, we instead get a class that shows the different properties we have on that class. And since this class is used by others, it makes a little use by down here. So the AI will know this class is actually being used by this system. Let's go back. So in the end, we end up with all these code entities that we need to check if they already exist in the database or the vector store. So in this case, we have a small get existing async. So this is essentially a kind of SQL statement saying, give me everything here, which is from this specific source with this specific collection. Nothing more than that. And what we get back, and if it's SQL, we get it from SQL as SQL. If it's Azure Omega Search, it will give it back as Azure Omega Search. And then we get all the vector entities, because a vector entity is all this we draw out of a chunk plus the content of that chunk as a opinionated, in my case, XML-like structure, so we can put it into the vector store. And then we go to every code entity and get the content, and we build our vector entity. So we just give it a new GUID. We give it the ID, the content source, and so on. So we end up with, all this information about that specific C# file. And then we check, is it already in there? So if all these columns are the same value, then it must mean that it already exists. In my case, it do exist. So I can just skip it and save my money on embeddings and such things. But if it doesn't exist, I need to offset it, insert or update, and that is just a simple call from semantic kernel. And I built in that if it's too big, it will end up splitting it in two automatically, dividing in the middle. But hopefully, most code should not be too big. It will keep track of what IDs it has added or what IDs to keep. And in the end, it will just do an excerpt of the IDs and figure out if there's anything it needs to delete. In my case, because I'm mostly up to date, it is almost done immediately, but else it will take a couple of minutes depending on how much you have. And then we are actually done with the ingestion of C#. And we go to the next source if you have more than one source. In my case, I have another source, which is Markdown. And this is more or less exactly the same procedure. It grabs the raw files. So now, if I go here again, it's now grabbing all the Markdown files I have in there. And then take those files, and instead of a chunker of C#, it does chunks of Markdown. So in case of Markdown, it splits by these hash symbols. So H1, H2, H3, and so on, all depending on your settings. In my case, I set it down to split down to the third level because that fits my data the most. And then it's just doing text manipulation. The other one was code analysis, but this is text manipulation. And at some point it gets back, makes a vector entity because they fit both code and Markdown. We get the existing ones and do exactly the same as before. So in this case, we are done with this, and we can see that once we get down to done here, because I have all the data again, else it would take a few minutes, and we are done with ingestion. And the process ends. In this case, it was this long one. It timed out because it took so long, but beyond that. The final thing is, of course, the search. And the search is very simple, and I have shown it in other videos. But there's a search endpoint in SimpleRag, and all it does is search with a search query and how many records it wants back. And it goes down into the vector store, do the vectorized search, nothing other than what we normally have seen, and gives the data back as a search result, which you then give back to an MCP server or whatever you need your RAG for. And that is actually everything. Again, lots of like 30 minutes here, but just telling about something that is quite simple in various steps. And this is my way of making it simpler for you. So with that, thank you. See you in the next one.